Hello, my name is Mr. Bryce, and we're going to take a look at some of these questions for a practice test. And the first question is, which of the following is irrational? I know there's a little typographical error there. So first of all, we have to know what irrational is. Irrational is a number that does not stop, does not repeat. So first of all, 8/3 is obviously rational because they're both whole numbers and it's written in fraction form. If we were to type that into a calculator, we would get 2 2/3, which is 2.6 repeating. It repeats, so that is rational, not irrational. The square root of 81 is 9. That stops. -17 obviously stops, so that's out also. The square root of 50 is 7 point something, and it does not stop, does not repeat. So the answer is the square root of 50. For each of the following numbers, place a greater than symbol or a less than symbol to compare the two numbers. Okay, now always use a calculator for this. So I use the calculator to convert those into decimals. And there are the decimals. Notice that those are negative. Okay, so we're looking for the number. The largest number is the number farther to the right. So if we were to make a number line, here's 0. Now, they both have a -1 in it. Okay, so let's just say there's -1. They both have a 0 as the next digit and a 9 versus a 5. So the 1.09, -1.09, is there, and the -1.05 is right there. So the -1.05 is larger, it's farther to the right. I don't understand it's farther to the right. Well, let's look at just a simple number line with 1, 2, and 3. Which is bigger, 1, 2, or 3? 3 is bigger, and it's farther to the right-hand side on the number line. That's why it's bigger. Now, when they're positive numbers, it's a lot easier to compare. So 4 compared with 4, they're exactly the same. The 7 and the 7, the 1 and the 1. Oh, so are these equal? Absolutely not. Even though it's not written there, these are filled with zeros. So 2 is larger than 0. These are positive numbers. So 3 pi over 2 is greater than 4.71. Use your calculator to get the proper decimal equivalent. You can use your tools in these situations. Which of the following is an integer? Okay. Remember, an integer is a positive or negative whole number. That's not a whole number. This is a whole number, but let's check. This is a very famous irrational number. This is also an irrational number. Okay, so choice A is rational, choice B is the integer, C is irrational, and D is irrational. Number 4, which of the following is an example of the associative property of multiplication? The first thing that we do is check to see if any of the answers are in addition, showing the associative property of addition. No, they're not. They're all in multiplication. Associative property means who are you hanging out with? Who are you associating with? So the order stays the same. X, Y, Z. Z, Y, X. We commuted them. Changed the order. Here, X, Y, Z, X, Y, X, Z. Nope, order changed. X, Y, Z, X, Y, Z. Okay, the order stays the same. 1X and just X. No, the order didn't stay the same. This one is the associative property because the parentheses moved and we still get the same answer. Number 5, which of the following is an example of the distributive property of multiplication? Well, first of all, this is nothing at all. Remember, the distributive property is where you're multiplying something through parentheses. we multiply the x times the y and the x times the z. xy plus xz. We distributed. We moved the x to the y and to the z. That's what distribute means. What's the additive identity? The additive identity for any number is 0. And if I take 0 plus house, it equals what? House. 0 plus x equals x. That's why it's identity. We're adding 0 to something, and we get that something right back. Additive identity. Don't get fooled because I specifically asked for the additive identity for number 121. Doesn't matter if I were to ask for the additive identity for 121, monster, house, or anything else. Evaluate each of the following. They are 3 points each. Evaluate just means find the mathematical answer. You can use your calculator. -5 times -2 is 10 plus 7 is 17. Be careful here. You can't type C into your calculator exactly the way it looks. Remember that fraction bar also means put parentheses around everything on the top and everything on the bottom. Just do the operations on top following order of operations. 3 times 5 is 15. You do parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. There's imaginary parentheses in a fraction bar. So this is 10 over 2, which is 5. Remember, if you have any questions, make sure you write them down and ask me either in class or right now if this happens to be in class. Okay, that's the end of the page. I won't scroll down anymore. I wanted to scroll it down so that we could see a closer look at this. It would help me a lot if you did what, Mr. Bryce? Gave more examples, gave more explanations, gave us more time to do group work, gave us more homework, gave us less homework. I understand almost some or none of what we did last week, and I think I earned a certain percent on the grade. Make sure you answer the question because it's worth 1 point. Okay, each one of these are worth ½ a point each. See if you can discover the pattern. The square root of 4 is 2, square root of 9 is 3. Well, here 4 is the same as what number? We're looking for the square root of 16. 5 is the same as the square root of 25. The square root of 36 is 6, square root of 49 is 7. 8 is the same as the square root of 64. 9 is the same as the square root of 81, and 100 is just, 10. Now, it breaks my heart when someone says that 16 is the same as 4. No, it's the square root of 16 is the same as 4. Please, don't make that mistake on your exam. I have this on the first page so that when you're doing the test, you can use them as a reference table for the next questions. So the square root of 50 divided by the square root of 2, when simplified, is what number? Be careful. Do we know the square root of 50? No. Do we know the square root of 2? No. But since they're being divided, we can divide the numbers first and then simplify it. So 50 divided by 2 is 25. If we didn't do the square root operation, so it stays inside the square root. The square root of 25, wrong. Square root of 25 is 5. Simplify it all the way. Don't just stop. Square root of 48. There's nothing to be divided here. So we have to break this because it says simplify it. So there must be something to do. The square root of 48 is 4 times 12. But is there a larger perfect square hiding in there? Yes. 16. 16 times 3. Square root of 16 is 4. 4 square root of 3 is the answer. If we went the route of doing 4 times 12 and had 2 square root of 12, we're not wrong, but it's not simplified all the way. So what you have to do is 12 is the square root of 4 times the square root of 3. So it's 2 times 2, square root of 3, which is 4, square root of 3. Exactly the same answer as before. So here, what am I trying to find out? I'm trying to find out if you know the rule that you can multiply radicals. You can distribute through the radical sign. So this is the square root of 36. Square root of 72. I got ahead of myself. Don't get tripped up by the wrong answer. 72 is the square root of 36 times 2. The square root of 36 is 6, square root of 2. Make sure you jot down anything. You can hit pause at any time if I'm going too fast for you. Let's take a look at number 5. Still a 2-point question. Simplify completely. Can we do the square root of 49 divided by 4? 49 divided by 4 does not come out to be a whole number. Oh, I immediately recognize that 49 is a perfect square and 4 is a perfect square. So 49, the square root of it is 7, and 4, the square root of it is 2. So it's 7 over 2. Do not get caught by the distractors. The right answer is D. Show all work, no credit. Simplify completely. So you can't just write down the answer. You have to understand that 32 is 16 times 2. You put them in square root symbols. The square root of 16 is 4. The square root of 2 is the square root of 2. Not a lot of work, but there it is. No work, no credit for number 7. Notice that that's a 3-point question, so there's probably a little bit more work to do than the previous problem, which was only a 2-point question. Can I subtract radicals? Do not get fooled. We cannot do no. That's wrong. We have to get a common number inside the radical. Let's just simplify 12 as being square root of 4 times square root of 3. And 2 square root of 3, because 3 is a prime, we can't simplify it anymore. 5 times 2 square root of 3 minus 2 square root of 3. Okay, 5 times 2 is, get out my socks and shoes, is 10 square root of 3 minus 2 square root of 3. Now remember, it's just like 10x minus 2x is 8x. X represents any number at all, so this is 8 square root of 3. The square root of 3's do not go away. Make sure you ask questions. Do exactly the same thing for number 8. 9 times 3 is 27, and then 4 times 3 is 12. So if you know your multiplication tables, that's why it's so important. The square root of 9 is 3. The square root of 4 is 2. So this is 9 square root of 3 plus 10 square root of 3, which is 19 square root of 3. I'm going to erase these and move it up so we can take a look at what I think is the last question. Find the area in simplest form. Area is base times height. 4 square root of 5 times the square root of 20. I made this nice for you. 4 times 5 times 20 is 4 times the square root of 100. The square root of 100 is 10. So it's 4 times 10, which is 40. Now we can say it's 40 units squared. 40 units squared. Okay, because area is measured in how many squares fit in a specific spot. Okay, let's take a look at this.